Hello, this is Ms. DB, and today we are going to start Chapter 6. And the Chapter 6 is on polynomials, and we are going to start today with Section 1, which is kind of an overview of polynomials. So our objectives are to identify, evaluate, add, and subtract polynomials, and to classify and graph polynomials. So there's a lot of definition in this section. It's not super complex vocabulary, but there is a fair amount of new words to learn. So first of all, a monomial is a number or product of numbers and variables with whole number exponents. So that's a really complex way of saying that there's only one term. So you might have something like 3x, that's a monomial. You might have like 5. You might have just x. All of those are monomials. You can even have a monomial with an exponent, and x is not the only variable you can use. But these are all monomials because they only have one term. Mono means one term. A polynomial then is when you have some monomials added and subtracted together. So you have more than one term. So more than one term. And terms are separated with plus or minus signs. So a polynomial might have two terms, like 3x plus 4, or it might have 5 terms. As long as there are more than one term and they are separated with plus and minuses, 1, 2, 3, 4, then you have a polynomial. Polynomials don't all have to have the same variable. They just have to have more than one term. And again, terms are separated with plus or minuses. Polynomials have no variables in the denominators or exponents in the denominators. They have no roots or absolute values of variables, and all variables have whole number exponents. Whole numbers are like 1, 2, 3, 4. They're not going to have negative exponents. They're not going to have fraction exponents. And they won't have something like a variable in the denominator. They won't have exponents in the denominator that are on the variable. They won't have roots of variables, like the square root of x or the absolute value of x. So polynomials will just have the variable. It can have exponents, but the exponents need to be 0, 1, 2, 3, 4. Here's some examples of polynomials. These are separate polynomials. 3x to the 4th is 1. 2z to the 12th plus 9z cubed is 1. 1/2 a to the 7th is 1. 0.15x to the 101 is a polynomial. And 3t squared minus t cubed. So you can see they can look quite complex, but there's certain things that they won't have. And here's some of those things that they can't have. The variable cannot be in the exponent. You cannot have an absolute value sign around the terms. You cannot have a variable in the denominator. You cannot have a square root around the variable. And we will not have exponents that are not whole numbers. All right, next we're going to talk about degree. The degree of a monomial is the sum of the exponents of the variables. For example, let's look at these. It's the sum of the exponents of the variables. So in this one, there's only one variable, it's z, and it has an exponent of 6. Therefore, the degree is 6. In letter B, there is no variable, so the degree is 0. You could write that with x to the 0 because anything to the 0 power is 1, and 5.6 times 1 is still 5.6. So if there is no variable, no a, no b, no c, no letter, then the degree is 0. In C, there is more than one variable. The variable on the x is 1. If there's no number there for the exponent, it's actually 1. So we have to add the 1 plus 3, and we would get 4. The degree is 4 for C. And in D, we have to add the exponents on the variables. There's 3 variables, and the B would have an exponent of 1. So we have to add 2 plus 1 plus 3 is 6. So don't forget about, again, that the degree will be 0 if there is no variable. And if you have a variable with no exponent on it, add a 1 after that so that it makes it easier to find your degree. Here's just some more practice. So why don't you take a minute and see if you can figure out these answers, and then I will show you the answers. All right, so you should have gotten that 3 is the degree in A. In B, the degree is 0. In C, the degree is 5. And in D, the degree would be not 8, but 9, because B has an exponent of 1. You're going to do some of those on the worksheet as well, but they're just a matter of counting the exponents up, so I think you can do those without any help from me. If you have a polynomial and you have to find the degree, then you need to find the term that has the greatest degree. So find the degree of each monomial that makes up your polynomial, and then the one that is the highest degree, that's your degree of your whole polynomial. Also, if you're asked to write a polynomial in standard form, then you put the variable with the highest exponent first, and then you go down, 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 down. Also, if they ask you for the leading coefficient, that is the number in front of the first term. So the leading coefficient in this example is 5. And then you can find the degree of each one. The degree of 5x to the third is 3. X to the second, you would have a degree of 2. This would be x to the 1, so that's a degree of 1. And the constant at the end has a degree of 0. So standard form is when you write these in descending order. You sometimes will be skipping. You don't always go 3, 2, 1, 0. You might go 3, 1, 0 or 3, 0. But as long as the first term is the one with the highest degree, then it's in standard form, and then decrease after that. You can classify polynomials. Here's some more vocab. If you have 2 terms, we call it a binomial. Bi means 2. And if you have 3 terms, you call it a trinomial. So here we have a, this is also classifying by degree. So by degree, we have a constant has a degree of 0, like a constant, like no variable. No variable. Just a number. So that's a constant. If it's linear, it has just an exponent of 1, like x to the 1, like 3x plus 6. A quadratic is squared, so we have a highest degree is x squared. A cubic is x cubed. A quartic is when we have a 4th degree, and a quintic is when you have a 5th degree. So that's classifying by degree. So you can classify degree or by number of terms. If you have more than a trinomial, then we just call it a polynomial after that. So by number of terms, we have a monomial, that's just 1 term. We have a binomial, that's 2 terms. And we have a trinomial, that's 3 terms. After that, so greater than 3, we just call it a polynomial. We gave up on making special names. You might find some books that use special names, but we're just going to call it a polynomial after that. Okay, so now we're going to do some work here. We're going to rewrite in standard form, then name the leading coefficient, the degree, and the number of terms, and name the polynomial. All right, so we look for, to rewrite in standard form, we need the highest degree first. So this has a degree of 0 because it's a constant, no variable. This has a degree of 2 because the variable has a 2 as an exponent, and this has a degree of 1. So the highest degree is the middle term here, and it has a negative in front of it. So that sign has to go with the term when we rewrite it. Then I would put the plus 4x, and then I would put plus 3. This is a positive number, so you put a plus there. This is now in standard form. Once it's in standard form, it makes it easy to answer these rest of these questions. The leading coefficient is the number in front, so the leading coefficient is 5. Oh, negative 5 is negative 5. The degree is 2, and the number of terms is 3. We have 1, 2, 3 terms. We would name this trinomial, I already said it, we would name this polynomial as a quadratic, because it's got a squared as the highest degree. And it's also a trinomial because it has 1, 2, 3 terms. So it's a quadratic trinomial. Now in B, this has a degree of 2, this has a degree of 0, and this has a degree of 4. So when we write these, we have to put the 8x to the 4th, and since the sign in front of the 8x to the 4th is positive, is a plus sign, then that's what we would write first. Let me go ahead and get to that one. So we would have 8x to the 4th plus 3x squared minus 4. And then you next have to, let's see what's next, name the leading coefficient. That's just the number in front of the first term once you write it in descending order. So that's 8. It has a degree of 4 because that's the exponent of the highest degree. It has 3 terms, and this time it is to the 4th power, which was a quartic. And again, it's a trinomial because it has 3 terms. And you can certainly refer back to the charts in order to make sure you're naming these correctly. Here's your examples from your worksheet. Let's see if there's any that look tricky. Let's do number 7. So in number 7, it's got 1, 2, 3, 4, 5 terms. That's a lot of terms. Let's write the degree of each term above it. So the first term would have a degree of 2 because the exponent is 2. This has a degree of 4. This has a degree of 1 because really there's an exponent of 1. This has a degree of 3, and this has a degree of 0. The highest degree here is 4, so that's your first one that you write. The next lowest after that, or the next highest after that, would be 2x cubed, but there's a minus in front of it, so we write that sign has to come with it. Okay, we've got those two taken care of. Next would be the degree of 2, so that also has a minus, 3x squared. And then a 1, that's a minus as well. And then, let's see, we got that one, we got that. We need the plus 8 at the end. So 1, 2, 3, 4, 5 terms again. So it has 5 terms. It has a degree of 4. What is the leading coefficient? There's no number in front of this, so then you put that as a 1. You don't put a 0, you put a 1. There wouldn't be a 0 as a leading coefficient. To classify this, it has the highest degree of 4, which is quartic, like quart, 4 quarts in a gallon. And it has more than 3 terms, so we just call it a polynomial. Let's see, is there anything tricky on any of these other ones? Remember, this would have a 1 here if you want. I don't think so. I think you'll be able to get the rest of those. All right, now we're going to do some adding or subtracting. You can add or subtract polynomials. Make sure you pay attention to the sign in front of each term. We're going to be looking for like terms. Now, you may want to rewrite the like terms next to each other. In order to be a like term, it has to have the same variable and the exact same exponent. So here's a like term, 2x cubed and 1x cubed. I put a 1 there so I wouldn't just think it would 2x cubed plus x cubed is 2x cubed. When you add like terms, you add the coefficients in front. You do not change the exponents. What are they doing here? Oh, so they decided to write this one on top of each other, and they wrote both of them in standard form so it would be easier to see what goes where. And they even color-coded them for you. You don't have to do that. You can just say, okay, 2x cubed goes with 1x cubed, and that would be 3x cubed. And then is there any x squared terms? There's one right here, so that's the only one. It doesn't have to be added to anything. I'll just write it down. And then is there any x's? I've got a minus x plus a 7x. So I'd have minus 1x plus 7x would be plus 6x. And then I need my constants. Here's a 9, here's a 4, I get a 13. But you're certainly welcome to write them vertically and color code and do it that way as well. You should get the exact same answer either way. The parentheses matter a lot in subtracting. Be very careful with subtraction. Basically, you're going to be distributing through the negative through every single sign. So rewrite this as minus or negative x squared plus x minus 6. They wrote it in standard form, both of them. You don't have to do that stuff either. But you do have to make sure that it's minus x squared minus 6 plus x. This will change the sign of every single term in the second parentheses. And then you combine your like terms after that. Let's see, we have negative 2x squared minus x squared. So that would be negative 3x squared. You have only one x that's by itself, so you just write plus x. And then you have to combine the plus 3 and the minus 6. So 3 minus 6 is negative 3. This is another example. Again, look for your like terms. They have to have the exact same variable. So I'm just going to go ahead and write this. That's the only cube term. And then I'll put my x squared terms together. It's a negative 36x squared plus 6x. So that's negative 30x squared. And then, let's see, I took care of that. I took care of that. Oh, I didn't take care of the plus 6x yet. Plus 6x. There's no other x term, so I can just write that down. And then I need my constants of negative 11 minus 5 would be negative 16. Now the slide here shows writing these in standard form and then lining them up vertically and then adding your like terms after that, but you can see that it's the exact same answer. It's up to you how you want to organize your work. You only have to put the solution on the answer sheet, on the worksheet. Subtracting, make sure that when you subtract that this negative will be on every single term. It changes the sign of everything in the parentheses. So this becomes 5x cubed plus 12 plus 6x squared. Those don't change sign. And then that's the same as plus negative 15x squared minus 3x plus 2. I don't really need this either. So then when you combine your like terms, there's only one of these. These would go together. There's only one of these, and then these two would go together. So you should end up with 5x cubed minus 9x squared minus 3x plus 14. Here's the problems from your worksheet. Let's start number 9. The first parentheses is good the way it is, but then we have a minus sign. So I'm going to change the sign of all 4 of the terms that are in the parentheses. So I'm going to write minus 3x cubed plus 6x plus 4 minus 9x squared. Every one of these signs had to change to the opposite. If it was a negative, it changed to a plus. If it was a positive, it changed to a negative or a minus. And then you look for like terms. So let's see, my highest exponent is 3x cubed, negative 3x cubed. Is there any more cubes? Nope, so then you would start with that one, and the negative goes with it. And then next we're going to look for any x squared terms. There's 1, that's a 1x squared, and here's 1. So we have 1x squared, we could put that off to the side, 1x squared minus 9x squared. So really we're thinking to ourselves, what is 1 minus 9? 1 minus 9 is negative 8. So your next term would be negative 8x squared. Notice that we're not changing the exponent, just the numbers in front. And then I look for any x terms. Let's see, here's a 6x. I don't see any more x terms, so I write plus 6x. And then I look for constants. Constants don't have a variable on them. I don't want to use red again. I already used it. How about purple? No, I used purple. I'll go with black. All right, so we have negative 8 is a constant and plus 4. Negative 8 plus 4 is negative 4. So you put that as your constant at the end. So here's your polynomial with all of your like terms added together. All right, moving on. Here's an application problem. It says that the cost of manufacturing a certain product can be approximated with the equation, the function f of x equals 3x cubed minus 18x plus 45, where x is the number of units of the product in hundreds. Evaluate f of 0 and f of 200. So that's pretty basic. You're just going to replace all the x's with 0 and simplify, and then you'll replace all the x's with 200 and simplify, and then explain what your profit would be, or the cost would be. Sorry, it's cost, not profit. So when you plug a 0 in, you just get 45. So at 0 products, when you're not manufacturing anything, it still cost $4,500. Is this hundreds, the cost? Actually, I don't know. And when you put 200 in, you get a huge number. And then the initial cost then, that's what this one is. Our initial cost is 45. I don't know if that's $45 or what. It doesn't really explain. And then f of 200, this is the cost of manufacturing. Remember, 200 has to be multiplied by 100 because it's the number of units times 100. So that's the cost of manufacturing 20,000 units. So it's a much larger cost, of course. Here's the problem from, I'm not going to do this one. You guys can look at the solution if you like. This is the one from your worksheet. It says the height h in feet of a baseball after being struck by a bat can be approximated by h of t equals negative 16t squared plus 100t plus 5. This is a quadratic. It's similar to what we looked at in Chapter 5 on quadratics, where t is measured in seconds. Evaluate h of t for 3 when t is 3 and t equals 5. So you don't even have to explain what it means, but it would be after 3 seconds, this is my height. After 5 seconds, this is my height. So all you have to do is put 3 in everywhere that you see a t, and then simplify. Now don't forget your order of operations. You need to do your exponents first. So you'll get 9 there, and then multiply by the negative 16. So you'll have negative 16 times 9, plus and multiply that, 300 plus 5, and then do this multiplication before you continue. And don't add the 300 plus 5 together. You have to add these two together, and then you'll add 5 to that answer. And you'll repeat this for when you have 5 for your t value. All right, we're going to be using graphing now for these functions, polynomials. You can use a graphing calculator, and it'll look similar to this. And we can describe the graph and say how many zeros it has, how many real zeros, because there might be imaginary zeros that don't show up on the graph. Well, they will show up, but we'll talk about how to find the imaginary zeros later. But right now we're looking for real zeros, which is where it crosses the x-axis. So in A, we have 2x cubed minus 3x. So we graph this using either Desmos or Sketchpad or your graphing calculator. And to describe it, we might say, well, let's see, from left to right, first it increases, right? And then it reaches this little peak, and then it starts to decrease, and then it increases again. It crosses the axis 1, 2, 3 times, so there appear to be 3 real zeros. In B, we could say, well, first it increases, then it decreases, then it increases, then it decreases. And it crosses the x-axis 1, 2, 3, 4 times, so there are 4 real zeros. Here's a couple more examples. The first one is cubic. Cubic will always have 2 turns. It turns here, then it turns here. And the next one is a quadratic, like we looked at last chapter. So you might say that this is a parabola that opens upward. You could say it decreases and then increases. There are no real zeros because it never crossed the x-axis, although we know that there are some complex zeros that we could find. Here's a couple examples from your assignment. You can graph these using Desmos, and then you're going to say, does it increase, then decrease, then increase? Does it decrease, then increase, then decrease? How does it go? Write that out. The zeros is how many times it crosses the x-axis. And that's it. You do the same thing for number 13. You don't have to attach your graph. So you can just graph this on your graphing calculator if you have one, or in another window in Desmos. You don't have to take screenshots and attach them. We're just kind of describing the graphs and saying how they change as you read from left to right, and how many times it appears, how many times it crosses the x-axis, so we can count the zeros. So that's it. I hope you learned a lot today, and I am available to go over any questions that you might have, so please feel free to send me an email or a text or come to my office hours. Thank you very much and have a great day.